We're trying to find the largest coefficient when we perform this expansion. 5x squared plus 1 over x quantity raised to the 7th power is expanded. Now there's 8 terms in this, and one way to do it would just be to use technology, but where's the fun in that? Okay, I want to show you a way to do this just based on logic and reasoning. There's 8 terms, and one of the terms is certainly 1 over x to the 7th. That would be the last term, and so you could think of this as 1 times 1 over x to the 7th if you want, and so that would make 1 the coefficient. So that's the one coefficient we can calculate quite easily. Okay, but we want to find the largest coefficient, and you can think of the coefficient as just the number in front of any variable term. Okay, now let's. I've listed the coefficients, and notice I didn't list the variables. There's no need to, because a coefficient by definition is just a number. All right. Now our very first term, of course, is 5 raised to the 7th power. Okay, that would be 5. This 5 raised to the 7th power right here. Our next term, using the binomial expansion theorem, is 7 choose 6. Now, y'all, 7 choose 6 is just the same thing. That's equal to 7. One way to think of it, it's the same as 7 choose 1, and there's certainly 7 ways to do that. Now, and that's just this part right here. And then 7 choose 5, the way you compute that, I'm not going to do all these, but 7 choose 5 would be 7 times 6 divided by 2 factorial. But 2 factorial is 1 times 2, which is 2. 2 goes into 6 3 times, so this would be equal to 21. So that's how you do, that's how you handle this. And again, I'm just using the symmetry of the binomial coefficient. 7 choose 5 is equal to 7 choose 2. 7 choose 4 is equal to 7 choose 3. Think of it like this. If you had a bag of 7 marbles and you take out 4, there's 3 marbles left. So there's just as many ways you can take out 4 marbles as 3 marbles, and so on. The reasoning extends to all of that. Okay, so let's go look at the list here, and let's look at the logic that we used. So 7 choose 6 times 5 to the 6th. The big observation here is that this coefficient is bigger than this coefficient without using a calculator. The reason is, the very simple reason is that 7 is greater than 5, right? So you see, no calculator required. There's absolutely no reason to pull a calculator out or any other form of technology, because 7 is bigger than 5, which makes 7 times 5 raised to the 6th bigger than 5 to the 7th. Because you can think of this as just, 7 is larger than 5, so that's very simple right there. Okay, now let's move along and take a look at, so what we're saying is that this second term is larger than the first term. Okay, now let's move along to the next term, the third term, 7 choose 5 times 5 to the 5th. Okay, now again, using the same reasoning, and we've already calculated that, that's 21, but notice that 21 is less than 25, but 25 is 5 squared, right? You see, that's why that's crucial. 21 is less than 5 squared, and I'll write 5 squared for emphasis, right? Again, no need to calculate this, because by reasoning, comparison, and just plain logic, we get that the third term is less than the first term, but we know the second term is greater than the first term, you see? So far our winner is this one right here. This right now, based on the reasoning we've done so far, would be the highest magnitude coefficient in the expansion. All right, and now similar reasoning right here. We get down to 7 choose 4. That's the same as 7 times 6 times 5 divided by 3 factorial, which leaves 35. But notice that 35 is much less than 5 cubed. You see how it's getting smaller faster. 21 is close to 5 squared, right? But 35 is much less than 5 cubed. 5 cubed is 125, right? So sometimes they'll put a double less than here. It's much less than 5 cubed, which is what you would need it to be just to have equality here, right? Because you have 5 to the 7th right here. Okay, folks? And y'all, something similar happens all the way to the very end. So let me put the vertical ellipsis ... vertically oriented. Okay, so ... vertical in a vertical way, straight line down. So you see that this we've proven here, and again, and I'll write similar reasoning. Okay, just similar thought process here, going downwards. And so what we have is 5 to the 7th is less than the second term, but all the other terms are less than 5 to the 7th. So that means the largest term is 7 times 5 to the 6th. So let me write that right up here. The largest term would be 7 times 5 to the 6th. Now, some people just let you leave it that way. There's no, I mean, it's just a matter of multiplying it out. If you've done much math and you have much of a memory for it, 5 to the 6th, what do we end up with when you do 5 to the 6th? It's 7 times 5 to the 6th is what, 3125 maybe? I think this is 7 times 3125. Or no, 31,625 maybe? 31,625. I'm not sure, folks. This is 7 times. But anyway, I won't do the arithmetic for you. This is just, this is the largest constant. And I think this might be somewhere, I'm not sure. I don't remember. It's not important. But they would take this in a competition. You can just write this as the answer, I believe. Okay. That is all. Thanks for viewing.